before we write too much down, I want to make sure that we're familiar with a couple of terms here. The first one you should know here is parallel. We talked about it right before we left for break. Parallel lines are two lines that do not intersect. So they might look like this. So you should know that term already. I want to make sure that you know the notation that we use. Because just like with congruent and perpendicular, we have notation for parallel. So what you might see separate from the diagram is these little double bars, double L's, railroad tracks, however you want to look at them. That's used to signal parallel. Just like we use the little upside down T to mean perpendicular, this means parallel. And so if I call this line M and this line N, then you might see something written like this, and you should know that that means that M is parallel to N. In the diagram, you might see these little arrows on the lines, and those little arrows on the lines are going to mean that the lines are parallel. Now, the other word that you need to know for today is transversal. And you'll see this word in all of the theorems you're about to write down. And what it means is this line that I'm about to draw that cuts through the parallel lines. A line that cuts through a pair of parallel lines. So, shoo, slices through it. So this line, let's call it T for transversal. So in this diagram, it's line T. Is that line that slices through the parallel lines. That's called a transversal. And what we're going to look at today is the angles that are created when we have this transversal slicing through the parallel lines. Because there are 8 different angles that are created. We have these 4 here, 1, 2, 3, and 4. And down in this area, we have 4 more. So here's angle number 5, 6, 7, and 8. And we're going to talk about different pairs or combinations of angles that we can have in this diagram. For example, we already know that like angle 1 and angle 4, those angles are across from each other, so those are called vertical angles. So that's something we're already familiar with. We already know that like angle 3 and angle 4, those 2 angles, if I put them together, create my straight 180-degree line. And so that's called a linear pair of angles that make a line. So those are all words that we know and should be familiar with. But we're going to look at some new types of angles here today. So our first type of angles are corresponding angles. And this is where you want to start writing down the notes. This is your first blank. Corresponding angles are 2 angles that I said that there were kind of 2 different groups of 4 angles. And corresponding angles are angles that are in matching spots in those groups, in the same place in both of the groups. So 2 and 6 are corresponding because they're both in the same spot in each of the groups. In this group of angles, angle 2 is on the top right. There it is. And in this group, angle 6 is on the top right. So they're both on the top right of each of their groups, and so they're corresponding angles. And so the nice thing about those corresponding angles is that they have to be congruent. They have to be congruent because they're in the same spot, and parallel lines means that they're not going to change the measure, and I'm looking at the same transversal. So those are corresponding angles, both in the same spot. Our next type are alternate interior angles. Alternate interior angles. And alternate interior angles are also going to be congruent. Reason they're called alternate interior angles? Well, the reason that we say alternate is because if I look at my transversal, my line that's slicing through, they're on different sides of the transversal. One of the angles, angle 4, is on the right side of the transversal, and angle 5 is on the left side of the transversal. So they're on different sides of the transversal. Angle 4 is on the right, angle 5 is on the left. So alternates. And an interior, if I think about my parallel lines here as borders, and if I shade in between those borders, this space in between the parallel lines is going to be my interior. So these two angles are in the interior, in between the parallel lines. So then guess what? We're going to call this space outside of my borders, outside of the parallel lines, that's going to be my exterior. So alternate, different sides of the transversal. Interior, inside the parallel lines. Now we're also going to have alternate exterior angles, and they're going to be congruent. So same idea here, alternate on different sides of the transversal. Exterior outside of the parallel lines. So the alternate exterior angles are also going to be congruent. We're going to have 4 of these different pairs in total. We're going to have corresponding angles. They're congruent. We have alternate interior angles. They're congruent. Alternate exterior angles. They're congruent. The last pair are the ones you have to be careful of because the others are congruent, but these type of angles are going to be supplementary. So be careful, watch out for that those type of angles are supplementary and not congruent. And these type of angles are consecutive interior angles. I'll also call them same side interior angles. Because I think that that's a kind of better description of what they are. Because same side interior, first of all, interior, they're on the interior, inside the parallel lines. But this time, I call them same side because they're on the same side of my transversal. 3 is on the left, and 5 is also on the left. versus my alternate when they were on different sides of the transversal. When I had one on the left and one on the right. And these angles are going to end up being supplementary, which remember means that they are going to add to 180 degrees. That's what supplementary means. They add to 180. So those are my types of angles. I have corresponding angles. They're congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Same side interior or consecutive interior angles are going to be supplementary. Here is where we're going with this. This is the next example in your notes. Here's where we're eventually going with this. I should be able to give you one of these measurements. So the example in your notes gives this measurement here. It tells you angle 2 and says that it's 55 degrees. And just based on that information, that angle 2 is 55 degrees, we can figure out all of the other angles in the diagram. You should be able to figure out all of the other angles in the diagram. So I want to give you a minute or two to actually try that. See how many of these angles you can come up with. Here's a hint for you, by the way, if you're looking at this problem. We said that these measurements, even when we were talking about vertical angles and linear pairs, our options here were angles that were congruent, like these are the vertical angles or any of those, and angles that were supplementary, which would be the same side interior, and if you find a linear pair there, those would be supplementary. So that means if they're congruent, your measurement should be 55 degrees. It should match angle 2. Or it should be supplementary to angle 2, which means they got to add to what? 180. And so adding to 180 means that the other angle had to be 125. So 55 and 125 add to 180. So your answers for all of these should either be 55 or 125 for each angle. So some of them will be 55, some of them will be 125. I'll show the answer to this when we come back and finish up these notes on Thursday. But let's look down at these two examples here to finish off today. We're going to solve for x. And it says justify your answers. When I say justify your answers, what we're looking for is what kind of angles do we have. So you're going to write down what kind of angles they are, and then you're going to use that to set up an equation. So we've done this before. What kind of angles they are? Well, these two angles, I could ask this as another question, but hopefully we practiced enough of them by now. Inside the parallel lines, one's on the left, one's on the right. That means they are alternate interior angles. More importantly, the alternate interior angles are congruent. So that means if I'm setting up my equation, I want to make them equal. Because they have to be equal. So what are my two measurements? 3x plus 15 is one of them, and then 60 is the other. And they have to be the same. That's what we're saying here. Ease back in with a pretty easy equation to solve. We're going to get rid of the adding 15 by subtracting. $16 minus 15 is going to be 45. Divide by 3 to get rid of multiplying by 3. 45 divided by 3 is 15. So 15 is our answer for x here. And as usual, if we want to check our answer, we can plug it back in. So 3 times x we said was 15 plus 15. 15, 30, 45, and another 15 is going to be 60. Hey, look at that. It matches the 60 over here. Just like our equation says it should. Just like the alternate interior angles says it should be 60. Questions on that? All right, we're going to start the next one. And then I want you to try and finish it on your own. This one's trickier. We still need to figure out which type of angle they are. It's trickier because these lines are not parallel. I just have 2 lines that are crossing. So if we're looking at what kind of angles we have, if we don't have any parallel lines, then we got to have none of the above. And so we need to think back, oh, I just have 2 lines that are crossing. Then we got to think back to chapter 1. We looked at this diagram back in chapter 1. So these angles, if I put them together, just make a straight line. So they are a linear pair. Pair of angles that make a line. And that linear pair is going to be supplementary. So this is a chapter 1 question. I could have asked this a few months ago. But I want to make sure that we're still keeping track of it in comparison to the other type of angles that we're looking at. Supplementary means when I add them together, then they should equal 180. So let's take our 2 angles and add them up to 180. My 2 angles are 6x minus 2. And then my other angle is 7x. And I'll let you finish up and solve this one. Make sure we still remember how to solve this equation here.